Assalamualaikum. Hi everyone, my name is Aimi Hanim from HIZAR. The open ocean covers more than 2/3 of the Earth's surface. Deeper than Everest, its height is the last frontier and is still largely unexplored. Yeah, it is one of the richest environments, home to the greatest diversity of life on this planet, from some of the largest creatures ever to live to the most grateful and the most feared. Humanity has a long history of exploiting the ocean genius harvest. We have become dependent on the ocean to always provide, and we assume it always will. But we are only just beginning to understand our impact on the increased population, with an insatiable appetite, put a growing pressure on the ocean. This means uncertainty for some species and the endangered list for others. High on that list is the Pacific bluefin tuna. Covered as a delicacy in Japan, a single fish can sell 4,000 at auction, and the increased demand drove us to fish them right to the brink. There are 3 species of bluefin tuna: Atlantic, Pacific, and Southern. They are found in the surface and subsurface temperate water and are capable of diving to depth to 500 and 1,000 meters. The largest of all bluefin species is the Atlantic bluefin, which can live over 40 years, weigh over 600 kilograms, and grow over 3 meters. Bluefin tuna are slow to mature, and some of may not reproduce until they are 15 years old. Of the 3 species of bluefin tuna, the Pacific bluefin tuna has a unique characteristic. The body shape of this fish resembles a teardrop, which is the most hydrodynamic shape possible for fish, given that water is around 800 meters thicker. Possessing this streamlined shape is the key in making Atlantic bluefin move through the water. The tail of the tuna is the primary force behind the bluefin's movement and is stiff, narrow-bladed, and swept back from referred to as lunate. The horizontal quills on the caudal peduncle allow the tail to cut through the water as swings from side to side, reducing water resistance. Bluefin are endothermic, which means they can actually regulate their body temperature a couple of degrees warmer than the surrounding water. Within its first year of life, it developed something known as regional endothermy, the ability to regulate its body temperature. The Pacific bluefin gets oxygen from the cold water ocean using its gills. This process cools its blood. Then, heat of the tuna generates swimming and hunting warm the blood. In most fishes, this heat would be lost back out into the ocean through the gills. This mechanism, called counter-current exchange, traps the heat. Cold blood on its way to the large swimming muscle passes close to the warm blood, leaving those muscles in a specialized network of blood vessels known as retal mirable. Here, the heat jumps into the cold blood to stay in the body. This makes bluefin one of the few warm-blooded fishes, a huge advantage in the marine environment. Cold-blooded animals whose body temperature depends entirely on the environment become sluggish in colder water. That's why we never can buy a live tuna. Although tuna are among the fiercest fish in the ocean, they die as soon as they are brought ashore. In fact, even in the sea, they die instantly if they ever stop swimming. This is because tuna breathe through a process called ram ventilation, which means they must keep moving to let the water flow over their gills, constantly supplying them with oxygen. This is true even they are sleeping. That's why once a tuna is caught and brought ashore, it must be processed quickly and then frozen. Bluefin tuna can reach speed few other animals can match. Their maximum speed is 40 miles per hour. It's faster than a Great white shark, or orca whale, and even at their comfortable cruising speed, they can cross the Atlantic in a couple of months. All this swimming requires a great deal of oxygen, but the bluefin is adapted for this as well. The faster it swims, the more water passes over its gill, and the more oxygen it can absorb from the water.
Pacific bluefin tuna plays a crucial role in marine ecosystem and has significant importance to other organisms. First of all, they contribute in nutrient cycling. So, when tuna consume their prey species, they assimilate and metabolize the nutrient present in their bodies. Then, through excretion in the form of waste, these nutrients are released back into the water and then enrich the surrounding environment and benefiting the entire food web. Secondly, bluefin tuna is a keystone predator, which means that their presence and behavior have a big effect on how the marine food web is built and works. As a top predator, bluefin tuna helps contribute to control the number of its prey species, which affect the number and location of these animals on the lower food chain. The Pacific bluefin tuna has been subject to intense fishing pressure, driven by high demand in international markets, particularly for sushi and sashimi. The combination of extensive fishing effort targeting both adult and juvenile bluefin tuna has led to a significant decline in population numbers, which also known as illegal, unreported and unregulated IUU fishing. Illegal fishing such as exceeding quotas and unreporting catches and fishing during close season. The situation becomes even worse when tuna is also harvested at their spawning ground in Japan. Despite their slow growth rating and reproduction, tuna is really affected by overfishing, and because of this issue, Pacific bluefin tuna are now listed vulnerable in IUCN Red List, which means they are not endangered yet, but without any protective measures, they will be. Conservation efforts of Pacific bluefin tuna are in place, but are location specific. Emphasis has been placed on reducing commercial intake of young, less than 3 years old bluefin tuna in multiple areas, especially in Japan and Korea. An upper limit of metric tons per year has been set in Mexico and United States. Reported catches in the US have been lower in recent years. Only after heading south into waters near Mexico have been catch number increase. Recreational fishing in California also have been restricted. Since 2015, the catch limit has been reduced from 10 to 2 per day. Some fish hatchery efforts are in place, but they are mostly involved in catching tuna in the wild and raising them for a couple years, or they include keeping and spawning individuals. There has been an effort to begin cryopreservation of semen as well.